In May 1849, in County Limerick, Ireland, it rains, but the rain is black, black as fresh ink. It falls for hours across 400 square miles of countryside. It stains the rooftops, marks the sheets hung out to dry, leaves dark puddles in the ruts of dirt roads. The farmers collect the substance in buckets, with the caution one reserves for things one does not understand. The water is dark, thick. It has a fetid smell and a taste that witnesses describe as deeply unpleasant. The chemists of Dublin receive the samples. They conclude it is a local phenomenon. Probably a distant industrial fire whose soot the winds carried over. The explanation is not proven. It is merely plausible. It will do until something better comes along. Except that nothing better ever will. A few years later, on the Scottish coast, at Slains, a small village battered by the North Sea. Same black rain, same ink-like consistency. It falls on January 14, 1862. It returns on May 20. It returns on October 28, 1863, then again and again. Between 1862 and 1866, 8 black downpours strike the same parish. The first two coincide with eruptions of Vesuvius. A cause is found. The ones that follow correspond to no known volcanic activity on Earth. The cause is lost. And then, after 2 of these showers, something else appears. Vast quantities of a solid substance wash up on the shore near the village, sometimes described as pumice stone, sometimes as slag. A chemist analyzes it. It is not a volcanic product. It is furnace slag, an industrial smelting residue. Furnace slag washed up on a Scottish beach, fallen from the sky. And the quantity, according to the Reverend James Rust, who documents the affair, would have required the combined output of every smelting works in the world. Charles Fort, who compiles these cases at the turn of the 20th century, finds this amusing. One would have to imagine, he writes, that discharges from Vesuvius cross the whole of Europe without settling anywhere, only to precipitate with the precision of a marksman over one small Scottish parish. 8 times in 4 years, then 3 more discharges, this time from Etna, targeting the same parish with the same accuracy. Fort offers an image. It is like an island on an oceanic trade route, receiving debris from passing vessels. But there is something else still, for black rains do not always fall in silence. In Northampton, England, in July 1850, a rumbling like that of wagons is heard for over an hour. 3 days later, a black rain falls. In Canada, in November 1819, a black rain is accompanied by shocks resembling those of an earthquake. At Comrie in Scotland, between 1839 and 1841, 247 tremors are recorded, accompanied by regular falls of a fine black powder. Black rains persist at the Cape of Good Hope. Then, in January 1911, in a Swiss canton. For this last one, the scientific journal Nature offers a remarkable explanation. In certain weather conditions, snow may take on an appearance of blackness. Fort translates ironically, it is not that the rain was black, it simply looked as though it were. Ireland had its soot, Scotland had its slag, the Cape had its winds, Switzerland had its optical illusion. 4 black rains, 4 different explanations, as though each file had been handled in isolation, in the hope that no one would ever open them side by side. But Fort opened them side by side, and what he found was not an answer, but a question. What if the fate of every explanation is to close one door only to see another swing open?